are in 14.3 moles of helium. You very clearly said, just multiply what?
14.3 by 6.02 by 10 to the 23rd.
Very good. It's very important to be conceptual, kind of get the big picture. What's really happening here? But then I'm going to show you how to do the calculation. First, non-negotiable. Write your given and your find. Let's go. Given. What was given? 14.3 moles. And we're going to abbreviate moles, M-O-L. Moles of what? Cows?
Atoms.
Moles of atoms? Moles. Atoms are in moles. So you can't have, so 14.3 moles of what? What? Helium. Non-negotiable. It should look just like this with the unit and the element or compound, whatever is given. All right? Next, find. What's find? What are we trying to find?
How many atoms?
Okay. Number of atoms. Questions, comments, concerns. Okay, let me show you how to do it. You're going to do a T-chart. You're going to put the given here. Then you're going to do something that I made up, the GallopWay. I made up this new word called diagonate. It is not a real word, but it helps my babies diagonate, understand the process. So don't go to college and tell your professor, next you diagonate, because it's not really a word, okay? It only works in this class, okay? So given, you put the given here, number one. Then you diagonate. What do you diagonate? What does diagonate mean? It means to bring your unit compound from here to here. And I said compound, but of course it can be an element or a compound here. And then these two must be equivalent.
Which two?
This one, these, and this. This and this should be equivalent. And then you should put what you're trying to find here. When what you're trying to find is in the top right, you're done. When what you're trying to find is in the top right of your T-chart, you're done. So now you're ready to find what you're looking for. Find number of atoms. If number of atoms is up here as your unit compound, you're done. If you're able to find what's equivalent to number of atoms after you diagonate, you're done. Questions, comments, concerns so far? All right, so let's practice. Let's take this one. Let me erase this because I might confuse you. What's going to go here? 14.3 moles helium. You don't have to write the of, but yes, very good. 14.3 moles of helium. Good. What's step 2? Allie? What is it? Diagonate. So what am I going to put here? What do we take over when we diagonate? The unit and the element. We do not take the number. So what are we going to put here? Not molecules, moles. Okay? So moles of what? Helium. Now you have to ask yourself, do I know how to go from moles to what I'm trying to find, which is what? Atoms. Do you know how to go from moles to atoms? Yes, you you do. I know that what? One mole equals what? 6.02 times 10 to the 23rd atom. So 1 mole, remember these two have to be equal, equals 6.02 times 10 to the 23rd atoms of what? Helium. Okay? These get crossed out. Now, you multiply the top and divide it by the bottom. Let me show you how to put scientific notation in these calculators. Get your calculator in your hand. Ready? 14.3 times 6.02 second. Y'all see the second on your calculator? Double E, which is directly above the 7, 2 blue capital E's. You see them? All right. So 6.02 second, double E, and you should see an E on your calculator. Do you? Now you're ready for your exponent, 23. Okay? And the answer is what? 8.6, okay, times 10 to the 24 unit compound. Atoms of, good. Anybody need me to show you how to put it in again?
Yeah.
All right.
Drink water.
14.3
Drink the water, nigga.
times 6.02 second, double E, 23 equals, yes. When we do second double E, that takes place of that times 10 to the 23rd. When we do second double E, 23. Got it? All right. Now, how would you ever? Is it likely that you will have an answer that says 5 atoms of helium?
Yes.
Yes or no? Raise your hand if you think you will. It's possible that it's likely that I have an answer that says 5 atoms of helium. Raise your hand. Raise your hand if you think it's unlikely if you'll have an answer that says 5 atoms of helium. I'm gonna need you to vote. Likely, unlikely. I'm gonna keep doing this until everybody's little hand raises. Likely to happen, unlikely. The answer is unlikely. Now I need you to tell me why. Why is it unlikely that you will get an answer that's like 4.5 atoms of helium? Because what? Well, no, not necessarily. Chemistry is not necessarily perfect. But why won't we have a number like 4.5 or 5 or 6 or 8 atoms? Why? What'd you say? Right. Atoms are so small. Remember, we use the mole because it takes up so many. We can put so many in that mold. So you will rarely see a small number for atoms or molecules or particles. You're going to see times 10 to the something. It's very, very rare that you will get an answer. I'm not saying it's impossible because, of course, you can make a calculation that gives you any answer. But for our purposes, you will very rarely see an answer where you will be putting 2 molecules or 8 molecules, 18 molecules. They're going to be very, very big numbers because they are very, very small. All right? Questions, comments, concerns? Let's try another one. of magnesium. Yes. Go ahead and set it up. It should take you 2 minutes flat to set this up. Don't forget the non-negotiables. Unit compound by every number. Unit compound by every number. Unit compound by every number. Also, before you even start, you write out the given and the find. All right, Eli, what goes first?
3.2 times 10 to the 12 atoms.
Where does that go? Here?
No, the one at the top.
Here?
Yeah.
Okay. 3.2 times 10 to the 12 atoms of magnesium. Raise hand if you got that far. You put it in the right place?
Yeah.
Did you put atoms?
Yeah.
Did you put magnesium?
Yeah.
Good. Josiah, what's next?
Keep one more. I mean, not one more. We have one more magnesium on the bottom right.
What's next? What's number 2?
11.
What's that called? Diagonate. Okay, so what does diagonate mean? In here. What does it mean? You don't know. I told you what it means. What does it mean? What do you do? You take the unit and the element. So what am I going to do? Hold on. Atoms and magnesium. You see how your diagonation leads you to the right? Because you were about to put moles here, weren't you, Josiah?
Yeah.
So atoms of magnesium. Did we bring down the number? Yes or no? No. The only thing we bring down is unit and compound, or unit and element in this case. Yes? All right. So what's next, Taryn? Okay, where?
At the top.
At the top?
Yeah.
If I put 6.02 times 10 to the 23rd, that's what? You gonna put that in front of moles?
Atoms.
Atoms? So where's atoms?
Beside.
Right here?
Yeah.
Right. So what am I gonna put in front of here? What number do I put here? 1 goes in front of what? Okay, to make it equal, it would be in front of moles. So what number do I put here?
No.
What goes in front of atoms? Remember I said, is it gonna be a big number or is it gonna be a small number in front of atoms?
1.
A big number. So you would never have 1 in front of atoms, or 2 or 3. I'm not gonna say never. Rare. It's not gonna happen. Okay? In here. So what number goes in front of atoms? 6.02 times 10 to the 23rd. And I know that is equal to what? 1 mole of what? Magnesium. Very good.
I'm not at the top.
Because you have to let your diagonation drive your problem. So atoms of magnesium gets diagonated here. And so in front of atoms goes to 6.02 times 10 to the 23rd. Okay? And we know that, remember, these have to be equal. 1 mole equals 6.02 times 10 to the 23rd. Let's do the calculation. Get your calculator in your hand. 3.2.
3.2.
Second. Double E. 12. We know it's times 1. We don't need to do that. Divided by 6.02. Second, double E, 23. Equals.
5.3.
5.3. What's after the 3? 5.3. Okay. 5.3 moles of magnesium. Question, comments, concern?
Would you put it in the calculator?
Yes, we'll put it in the calculator one more time.